Hello student, we are studying renewable energy sources course. In that we started our first chapter, that is an introduction to energy sources. In that we have covered the topics which are conventional and non-conventional energy sources, the characteristics of the sun, structure of the sun. These all are seen, these all the characters which have been seen in our previous video. Now in this video we will discuss new topic of our chapter first, and that is the electromagnetic energy spectrum. Now let's see electromagnetic energy spectrum. All substances, solid, liquid, gases at a temperature above the absolute zero emits energy in the form of electromagnetic waves. This is energy. This energy is called radiation. Now what do you mean by the radiation? The radiation is the energy which is emitted from the substances like solid, liquid, gases when they are at above absolute zero temperature. That means they emit energy in all directions. So this is called as the radiation. Now there are different types of the radiation which is present in our environment. So we know that the electromagnetic waves is the wave which has a transverse nature. That means electromagnetic waves are transverse waves. The wavelength of various electromagnetic waves falls in the wide range. There are two types of the wave generally, longitudinal wave and the transverse waves, but the electromagnetic waves are transverse in nature. The wavelength of the various electromagnetic waves falls in the wide range. That means the electromagnetic spectrum divided into different regions, and the wavelength of that regions varies so that there is a change in the frequency of that region. The electromagnetic energy spectrum is divided into different region which is shown in figure, that is the electromagnetic spectrum of the radiation. There are different regions in that spectrum, and so that according to that they have different wavelength and frequency. Solar energy reaching on the top of the earth atmosphere consists of nearly 8% UV radiation, that means ultraviolet radiation, and nearly 46% visible radiation and 46% IR radiation, that means infrared radiation. We know that the sun emits energy or light in all direction, and which is present in our earth atmosphere, and that consists of nearly 8% ultraviolet radiation, that is a very less amount, and 46% visible radiation and 46% IR radiation, that means the infrared radiation. This all consist, this is the composition of the solar radiation, that means the UV radiation, visible radiation and the IR radiation. Of the whole spectrum of electromagnetic waves, we can sense only that radiation which have wavelengths between the approximately 0.1 to 100 microns. That means we can sense only the radiation or the region of the electromagnetic spectrum which have the wavelengths between the 0.1 to 100 microns. We know that 1 micron is equal to 10 to the power minus 6 meter, and the range between 0.1 to 100 microns which we are able to sense the, that means the wavelength range of the electromagnetic spectrum. Next is the electromagnetic waves falling within these limits cause our body to heat up, and hence these waves are called as the thermal radiation. Due to this radiation, that means the radiation which falls within the wavelength range 0.1 to 100 micron cause our body to heat up. Therefore these waves are called as the thermal radiation. The thermal radiation consists of different radiation, that means they lie within the visible and IR range, but the visible light rays occupy very narrow band and the IR occupy large as compared to visible. That means visible light rays occupy very narrow band of thermal radiation spectrum. This is the information about the electromagnetic energy spectrum. Now this is the electromagnetic energy spectrum. As we see, if we consider the figure, there are different regions such as gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, and after that radio wave region. These regions has different wavelength as shown in figure, that is 0.001 micrometer, 1 micrometer, and this is the increasing wavelength. To the right side, if we consider the sine wave, the distance between the crust and troughs of the sine wave increasing towards the right, that means there is an increasing wavelength. We know that the relationship between the wavelength and frequency, that is c is equal to nu lambda, where c is the velocity of light, nu is the frequency, and lambda is the wavelength. From that we will get the inverse relationship between the frequency and wavelength, so that if we consider the increasing frequency region, there is a lowest wavelength. So in the right side, wavelength which will be increasing, that means in leftmost side the wavelength is in micrometer, and the towards right side it is in meter, that means the increasing wavelength. The leftmost part is the short wave radiation, and the rightmost part is the long wave radiation, that means the higher wavelength part and the lower wavelength part. Now the narrow region, that is the colorful region, which we'll see in a figure, that is the visible light, and the visible light covers the colors from the violet to red, and this is very small part, that is the visible part which present in the solar spectrum. So this is the electromagnetic energy spectrum. Now the electromagnetic spectrum according to wavelength and frequency, which are listed in the table. So let's see. First column is the wavelength in a micrometer, and the second is the electromagnetic radiation. The first electromagnetic radiation is the cosmic rays. The cosmic rays has wavelength which is less than 10 to the power minus 6 micrometer. That is the wavelength of the cosmic rays is less than 10 to the power minus 6 micrometer. That is the small wavelength and the higher frequency. So second electromagnetic radiation is the X-rays and gamma rays. The wavelength of the X-rays and gamma rays, it lies between 10 to the power minus 6 to 10 to the power minus 3 micrometer. Third electromagnetic radiation is the ultraviolet radiation, but it consists of three different parts, that is the far, middle, and near UV rays, and they have different wavelengths. So third is the far UV rays. The far UV rays wavelength is lies between 10 to the power minus 3 to 0.2 micrometer. The wavelength of the middle UV rays lies between the 0.2 to 0.315 micrometer. Now next is the near UV rays. The wavelength of the near UV rays lies between the 0.315 to 0.38 micrometer. Now next electromagnetic radiation is the visible rays. The wavelength of the visible rays lies between the 0.38 to 0.72 micrometer, and this is very small part which is visible to us. Next radiation is the near IR radiation. That is the starting of the IR radiation, and which has the wavelength of 0.72 to 1.5 micrometer. Now the next is the middle IR rays. The wavelength of the middle IR rays lies between 1.5 to 5.6 micrometer. Next is the far IR rays or far infrared radiation. The wavelength of the far infrared radiation lies between 5.6 to 1000 micrometer. Now next is the micro and radio waves. That is the microwave region and the radio wave region in the electromagnetic spectrum, and the wavelength of this region is more than 1000 micrometer. That means we know that the 1 micrometer is equal to 10 to the power minus 6 meter, and the wavelength of the micro and the radio waves which is larger than the or more than the 1000 micrometer. This is all about the electromagnetic radiation and their corresponding wavelengths in micrometer. There is also frequency and energy, but if we know the wavelength of the electromagnetic radiation, we are able to calculate the frequency of the electromagnetic radiation with the help of the relation C is equal to nu lambda, and after that if we know the frequency, then we are able to calculate the energy with the help of formula, that is the E is equal to h nu, where h is the Planck constant and which is a constant. So we are able to calculate the energy of the electromagnetic radiations. This is the electromagnetic spectrum, and which consists of different regions, that is the electromagnetic radiations. This is all about the electromagnetic energy spectrum. This is very basic information, but it is very useful in physics, so we have known about it. After that we will see the extraterrestrial radiation, that means the radiation, solar radiation outside the earth atmosphere, that means the solar radiation present outside the earth atmosphere, which we will see in our next video. So this is also known as the extraterrestrial radiation. So we will continue with that in our next video.